Welcome to Engineer's Mindset. Okay, so let's say we are given this network analysis and we are asked to use Maxwell's loop theorem to calculate the values of the current I1, I2, and I3 for this given circuit. Okay, so it's simple. Since we have about three loops here, we have loop 1, loop 2, and loop 3. So let's simply label here. Let this be loop 1, let this be loop 2, and let this be loop 3. Okay, so let's pick out these loops individually and analyze the network using Maxwell's theorem. So let's consider loop 1. Okay, so apply Kirchhoff's voltage law to loop 1. In loop 1, we simply have, I will break this down for easy understanding. I will break down the networks. So we have simply this. Okay, we have a resistor. Okay, we also have a resistor here. We also have another resistor there. All right, so this is all we have at loop 1. Okay, this is R1, 1 ohm. Okay, we have here R2, 3 ohms, and R3 to be 2 ohms. So we have R2, 3 ohms, R3 to be 2 ohms. So we have the direction of the current I1. This is actually 9 volts. Okay, so like I explained in the previous videos, I said this direction of current means current is flowing in this manner. So we have here, this is I1 also flowing in this manner through this resistor. This is also I1 also flowing here. This is also I1 also flowing here. This is also I1. But then if you take a look at the circuit, the general circuit itself, notice that on this resistor R2, we have current I2 also flowing in the reverse direction. So this is the direction of current flow in this circuit. So current here is actually in this manner. This is I2. We also have, okay, let's just pay attention to this first. Also in this resistor R3, we have this current R3 flowing through it, also in this manner. This is I3. So in these two resistors, we have current flowing here, I2. We also have current I3 flowing through this resistor, I3. So this is the circuit for the first loop. So employing KVL now, Kirchhoff voltage law simply states that the sum of the entire voltage on the circuit or on the loop must be equal to 0. So, and I said if current flows from negative to positive terminal, then the source becomes positive. The source here is 9 volts. And now take note, we weren't given whether positive or negative, but we are given symbols. This is actually a symbol for source. But since this is actually small, it means this is negative. And since this is larger than this point, it means here is positive. So there's a current gain or there's a voltage gain as current flows from here to this point. So the smaller one or smaller horizontal line shows negative, while the longer horizontal line shows positive. So even without imputing it, you should know that this is from negative to positive. So we have a potential gain. So we simply put that down as positive. So we have 9. Okay, this current I1 flows through the first resistor R1. So there's always going to be what? A potential drop whenever a current flows through a resistor. Because of that potential drop, we always attach minus times potential difference, which is resistor times current. And resistor here is R1, and the value of R1 was given as 1. So you simply have 1 times I1, which is the current flowing through it, I1. Okay. Same thing here now. I have this same current I1 flowing through this resistor R2, but not just that current, I also have I2 flowing through that same resistor in the opposite direction. But since I'm on loop 1, then remember if current flows through a resistor, always there's going to be a potential drop. So you put down your what? Negative sign, which shows potential drop. Now, since these currents are flowing through this resistor in opposite direction, I have I1 coming down and then I have I2 going up. But then I'm on loop 1, it simply becomes I1 minus I2. I1 minus I2 simply because I'm on loop 1. Okay, and that difference is because also they are moving in opposite direction times the resistor, which is simply 3 ohms. You have this. Also, I have I1 flowing through this resistor R3, and I also have I3 flowing through that same resistor in the opposite direction. Same thing, whenever current flows through a resistor, there's always a potential drop, so always put your minus. Then you have, since I'm on loop 1, it becomes I1 minus I3, and multiply this by what? The resistor, which is 2 ohms, times 2. The whole of this is equal to 0. So this is the entire voltage on what? The first circuit. So you may, sorry, on the first loop. So you may wish to now expand the brackets. Let's do that now and see. I have here 9 minus, of course, 1 times I1C gives us I1, okay, minus, so let's expand with 3 here. 3 times I1 gives us 3I1 minus 3I2, okay, minus, same thing here, 2 times I1 here gives us 2I1 minus 2I3, and this is equal to 0. So let's expand with negative signs. I have here 9 minus I1 minus 3I1 minus multiplies 3 gives us minus 3I1 minus times minus here is plus 3I2. Same thing here, minus multiplies 2 gives me minus 2I1 minus times minus here is plus 2I3, and this is equal to 0. Okay, so I have 9 minus, so observe here now, I have minus I1, let's collect like terms, minus 3I1, okay, I also have minus 2I1 here, minus 2I1, okay, plus 3I2, plus 3I2, plus 2I3, and this is equal to 0. Okay, so from here now, minus I1 minus 3I1 minus 2I1 simply gives us minus 6I1. So I'll simply have 9 minus 6I1, okay, plus 2 plus 3I2 plus 2I3 equals 0. Simply call this equation 1. Okay, next is to consider the second loop. So we consider the second loop, which is here. So let's bring out the loop. Let me break it down as well. Let's bring out the loop. I simply have here, okay, I have this, and I have this, okay, I have this. All right, so resistor here is R2, and R2 was given as 3 ohms. Okay, resistor here is R5, and R5 was given as 2 ohms, and resistor here is simply R4, and R4 was given as 1 ohm, and I have the direction of current of I2 in this manner. Current is moving in this manner. This is I2. Okay, so which means the direction of flow of this current is actually what? Up here, I2 in this way, I2, okay, through this resistor, I2, and through this resistor also I2. We have this. But not also forgetting that current I1 is also flowing through this resistor R2. So we have I1 also flowing through this resistor R2. So which means we have a current flowing here already, and that is simply current I1. Also not forgetting that on the resistor R4, we have this current flowing in this manner through this resistor. Current I3 is also flowing through the same resistor R4. So we have a current flowing in this direction, okay, through, that's simply I3 flowing through R4. So it flows in this direction. Okay, so you have that current I3. So this is now the diagram or the loop for the second diagram for the second loop. Okay, so let's also apply KVL now. Applying KVL to loop 2. Okay, same thing now. So since I have current I2 flowing through this resistor, 3 ohm resistor, there is always going to be a potential drop. For that reason, I have minus, which shows potential drop. But then it's not just I2 that is flowing through this R2. I have I1 also flowing through the R2, but in opposite direction. But since I'm on loop 2, it simply becomes I2 minus I1, difference in those currents, okay, times the resistor. That gives us the potential difference. And the resistor is simply 3 ohms, so multiplied by 3. I have this. The same current I2 flows through this R5 resistor, okay, and whenever a current flows through a resistor, there's always going to be what? A potential drop, which indicates minus. So we simply have minus the current I2 times the resistor. R5 gave us simply 2 ohms, so minus 2I 2, okay, and also I have I2 flowing through R4 resistor, but also I have current I3 flowing through that same resistor, okay. I also have this same current I3 flowing the same resistor R4. So I will simply now have simply, first of all, minus, because there is what? A potential drop whenever current flows through a resistor, and then the difference in the currents. Now since I'm on loop 2, it becomes I2 minus I3 times the resistor. The value of the resistor is simply 1 ohm, so times 1. So this is the whole potential drop or potential difference in that loop. The whole of this is equal to 0. So we simply have this. Okay, so let's expand this bracket now. This is minus into 3 times I2 gives me 3 I2 minus 3 I1, close your bracket, minus 2 I2, okay, minus into this I2 minus I3. Of course, 1 multiplies all remains that same value, equal to 0. Now let's expand the negative sign. Minus times 3 I2 gives us minus 3 I2, minus times minus 3 I1 gives us plus 3 I1. Here I have minus 2 I2, minus times I2 gives me minus I2, minus times minus I3 gives me plus I3, and this is equal to 0. Alright, so from here now, I can collect like terms. I have here minus 3I2, I have minus 2I2, and I have minus I2, okay, plus 3I1, okay, plus I3, and this is equal to 0. So if I bring everything here now, minus 3 minus 2 minus 1 simply gives me minus 6I2, okay, plus 3I1, okay, plus I3, and this is equal to 0. So I can call this equation 2, okay. So that's the equation for the second loop. And finally, for the third loop, we simply have, okay, considering the third loop, we have, let's break it down as well. Okay, we have here R4. We also have, okay, all right, so we have R4 1 ohm, 1 ohm. We have R3 2 ohms. We have R3 here 2 ohms, and finally we have R6 5 ohms, R6 5 ohms, and direction of current is in this manner. This is I3. So we simply have this. So this simply implies that current flows in this direction. We have I3 flowing through this resistor. We also have I3 flowing through this resistor. And we also have I3 flowing through this resistor. That's the manner of flow of the currents, okay, according to the loop or the cycle given there. But not also forgetting that current I1 flows through what? R3. Of course, current I1 flows through this same resistor R3. So we have this current I1. So we indicate that here we have current I1 in this manner. Okay. Also, we have current I2. Of course, current I2 flows in this manner in R4 because this is the direction of flow of the current. So it flows in this manner into R4. So we also state direction of that current there. We have a current flowing through this resistor. This is I2 in R4. So that's all. So we also apply KVL. Simply the sum of the entire voltage equals 0. Now we start from arrow 3. We have current I3 flowing through this resistor R3, but then again, we also have current I1 flowing through that same resistor. So two different currents are flowing in opposite direction. But since I'm on loop 3, that means I will always start with I3. So difference becomes I3 minus I1. But first of all, because current is flowing through a potential difference, there's always going to be a potential drop. So we'll attach our negative minus, which shows potential drop, open bracket. The difference between the two currents flowing through that resistor, first is I3, since I'm on loop 3, minus I2, minus I1, okay, minus, again, I have this current I3 flowing through this resistor. I have this current I3 flowing through the R4 resistor, which is 1 ohm. Because a current flows through a resistor, we also have what? A potential drop. So you put down your minus. But notice now that it is not only I3 that is flowing through that resistor. We also have what? I2 flowing through the resistor in opposite direction, as can be seen here or as can be seen on the main diagram. Okay, we have I2 also flowing in opposite direction. But since I'm on loop 3, it becomes I3 minus I2, okay, multiply by what? The resistor. And the value of the resistor is simply 1 ohm. So multiplies 1. And finally, I have I3 flowing through this resistor, R6 resistor, and the value is 5 ohms. Okay, so whenever a current flows through a resistor, there's always potential drop. So minus 5 times I3. The whole of this is equal to 0. That's the entire voltage on that loop. So we equate that to 0. Okay, so let's okay, sorry, this is I3 minus I1 times the potential difference, which is 2, times the resistor, which is 2. So not forgetting there is 2 here. Okay, so let's expand the brackets now. I have minus 2 times I3 gives me 2I3, minus 2 times I1 gives me 2I1. Okay, minus, same thing here, 1 multiplies everything here, remains the same. So I have I3 minus I2, okay, minus 5I3 equals 0. So let's expand now with the negative signs. So I have here minus 2, minus times 2I3 gives me minus 2I3, minus times minus gives me plus 2I1, okay, minus times I3 gives me minus I3, minus times minus I gives me plus I2, minus 5I3 equals 0. So let's collect like terms in I3. I have here minus 2I3, I have minus I3, I have minus 5I3, okay, plus 2I1, okay, plus I2 equals 0. And if we do this, minus 2, minus 1, minus 5 actually gives us minus 8I3. So I have minus 8I3, okay, plus 2I1, okay, plus 6 plus I2, and this is equal to 0. So simply call this equation 3. So we simply have 3 equations because we have 3 different loops in the circuit. So we have 3 different equations. So all we need to do now is simply solve these equations simultaneously and obtain the values of I1, I2, and I3. So choosing any suitable method at all to solve this simultaneous equation. All right, so you notice now that we have 3 equations having 3 unknowns. So this will be a little bit difficult trying to use either elimination or factorization method to solve this equation. So the very easier method to use, I will encourage you to use, is actually to employ the matrix method of simultaneous equation. Okay, because we have 3 unknowns, so it becomes easier and very easy with matrix. So we're going to use the approach of matrix to solving this equation. So before doing that, let's get down the 3 equations and rearrange them in terms of I1, I2, and I3. Let's rearrange them in terms of that order. I1 comes first, followed by I2, and followed by I3. Let's do that over here and see. So from equation 1, we had 9 minus 6I1, okay, plus 3I2 plus 3i2 plus 2i3 equals 0. So what we'll do is, let's simply send all the terms here over to this side of the equation, leaving 9 here as a constant. So if I send minus 6 over here, it becomes positive. I will simply have plus 6i1. If I send plus 3i2 over here, it becomes negative. It becomes minus 3i2. Same thing, if I send plus 2i3 over here, it becomes negative, minus 2i3. And this is now equal to, so I'm left with 9 on this side. Let's call this equation 1. So that's rearranging equation 1. Also equation 2, let's also write equation 2 in terms of I1, I2, and I3. So we have here I1 coming first becomes 3I1. So I will simply have here 3I1 minus 6I2, okay, minus 6I2 plus I3 equals 0, plus I3 equals 0. That's equation 2. And finally, the third equation, also we can write this in terms of I1, I2, and I3. It becomes 2I1 plus I2. So we have 2I1 plus I2 minus 8I3 minus 8I3 equals 0. Minus 8I3 equals 0. Equals 0. This is equation 3. So we have the equations now in terms of I1, I2, and I3. So which means we can actually write this equation in terms of matrix. And if we do it in terms of matrix, we are going to have, okay, this is simply a 3 by 3 equation. So we have our matrix 6, 3, and 2, which is 6, 3, and 2. Next column is minus 3, minus 6, and then the coefficient of I2 here is 1, so simply 1. Next column here is minus 2, okay. Column of coefficient of I3 here is 1, so simply 1, and here we have minus 8. Okay, this is a matrix all into I1, I2, and I3, okay, and the whole of this is equal to the constants, which is 9, 0, 0. So that's how you write this equation in terms of matrix. So simply 632, minus 3, minus 6, and 1, minus 3, minus 6, and 1. I have here minus 2, 1, minus 8, minus 2, 1, minus 8, all into I1, I2, and I3, which is this, and equal to their constant. So you simply have this. Okay, so what you do now is simply let A, you say let A, okay, let me do that over here. All right, so you simply say let A be equal to the whole of this matrix 632, okay, 2, minus 3 minus 6, 1, minus 2, 1 minus 8. So we simply say let A be equal to the whole of this matrix. And if A is equal to this, what you do now is to find determinant of A. So find delta A or del A, determinant of A. Find determinant of A. Okay, simply, okay, we can use bar to signify that determinant of A, and that's simply equal to, now we have a 3 by 3 matrix. To find determinant of a 3 by 3 matrix, the first thing to do is simply, remember, always from a 3 by 3 matrix, the arrangement is here is always plus, here is negative, and here is plus. So it continues like that till, okay, any number of matrix you have. So the first is always plus. So you block the row, you block the column. If you block this row and this column, I'm left is simply minus 6 and 1, 8 and minus 1. So simply block row and column, and you're left with minus 6, 1, 8, and minus 1. So you simply have, so you pick out the value you have there now, 6 plus 6. The first is always plus, then you put down minus 6, 1, 1, and minus 8. The next is what? Minus. So I showed that here. After plus, next is minus. So after plus, next is minus. So you block this entire row. So you block this entire row and block this entire column. So you block this and block this entire column. The entire row and the entire column is blocked. So you're left with 3, 2, 1, and minus 8. So for here you have minus 3. So you put that down, minus 3. Okay, block the entire row. So you're working now on the minus. So minus 3, block this row, block this column. You're left with 3, 2, 1, and minus 8. So you put down your determinants. 3, okay, 2, 1 and minus 8, 1 minus 8. And finally, the last is plus. So you block this row. You're now on this last column now. So you block this column and block this row. So we're working with minus 2. So you put down minus 2, open your determinant bar, block the row, block the column. Your left is 3 minus 6, or 3, 2, minus 6, and 1. So you have 3, 2, minus 6, and 1. So that's how you find determinant of a 3 by 3 matrix. So determinant of A becomes equal to plus 6. Open your bar. Now it is simply the product of the major row minus the minor row. So this is the major row. So you simply have minus 6 times minus 8. So the product of the major row minus product of the minor row, which is 1 times 1. So you have this. Okay, now notice here I have minus minus is plus, so I have plus 3. Open your delta bar. So same thing, product of the major row, I have 3. This is 3 times minus 2. Okay, minus product of the minor row, I have here 2 times 1. Okay, finally, of course, plus and minus becomes minus 2. Open your delta bar. Same thing. Alright, so here now, minus plus gives us minus 2. Put down your determinant bar. So the product of the measure, which is 3 times 1 here, 3 times 1 minus product of the minor, which is 2 times minus 6. So we have 2 times minus 6. Put down your determinant bar. Delta A is now equal to, this is 6. Put down your bar. Minus 6 times minus 8 simply gives us plus 48. Minus 1 times 1 gives us 1. Put down your bar. Plus 3 into 3 times minus 2 is minus 6. Okay, minus 2 times 1 here is 2. Put down your bar. Minus 2 into 3 times 1 here is 3. Okay, minus 2 times minus 6 simply gives us plus 12. Put down your bar. Delta A is now equal to, this is 6 into 48 minus 1 is 47. Okay, plus 3 into minus 6 minus 2 is simply minus 8. Okay, minus 2 into 3 plus 12 is simply 15. We have this. So determinant of A is now equal to 6 times 47. That gives us 282. 3 times minus 8 is minus 24. Minus 2 times 5 is minus 30. So this actually implies that determinant of A is actually equal to 282 minus 24 minus 30. That simply gives us 2, 2, 8. So this becomes determinant of that matrix A. Alright, so we've gotten the delta A. The next thing now to find is we'll form a new matrix. In order to find I1, I2, and I3, we simply form a new matrix. Now in this matrix, this column is actually the column for I1, this is the column for I2, and this is the column for I3. So to obtain I1, we form a new matrix simply called that A to the power of I1, which shows a matrix of A in the column of I1, and then we represent the whole of this column I1 with the values of the constants 9, 0, and 0. So we form a new matrix on that place. We call that matrix A to the power of I1. Okay, meanwhile, all the columns of I1 will now be represented by what? The constants. Let's do that over here and see. Okay, so we form a new matrix now. We'll simply call this matrix A, I, 1, okay, and that's equal to, so we form the matrix. The whole of the column of I1 will now be replaced by the constant 900. So we simply have 900, and then we'll have here minus 3 minus 6 and 1, minus 3 minus 6 and 1. Finally, we have minus 2, 1 and minus 8, minus 2, 1, minus 8. So we simply have this. So the next thing to do is to find the determinant of this matrix. So a to the power of I1, find the determinant of this matrix. Okay, so we'll put down our delta bar. That's 900, okay, minus 3, minus 6, and 1, minus 2, 1 and minus 8. So remember, in determinant matrix, the first is always positive, this is negative, and this is positive. Okay, so we have to find the determinant of this matrix now. Therefore, determinant of matrix A1 is now equal to AI1 is now equal to, okay, so to find this matrix, we start with the very first number, which is 9. Remember, here is plus, so you put it down, plus 9. Put out your determinant bar. So we simply block the whole of this row and the whole of this column. All we are left is minus 6, 1, 1 and minus 8. So we'll put it down. Okay, so we have minus 6, 1, 1 and minus 8. The next row, we move on to the next column, which is minus here, but we'll have minus 3 here. So first of all, you put down this minus and put down the very first value in that column, which is simply minus 3, close, put down a determinant matrix. Now you block the whole of this column and you block the whole of this row. You're simply left with 0, 0, 1 and minus 8. Okay, you have 0, 0, 1 and minus 8. So you put it down, 0, 0, 1 minus 8. And finally, you're on the last column now. So the last column is positive, so you put it down plus. You put down the value there, the first value there, which is minus 2. Okay, so you put down a determinant bar. So you close this row, this column, close the row, you're left with 0, 0, minus 1 and 6. 0, 0, minus 1 and 6. So you put it down, 0, 0, minus 6 and 1. Okay, 0, 0, minus 6 and 1. All right, so determinant of matrix AI1 is now equal to, this is 9 into, so determinant is simply the product of the major arm minus the minor arm. So you have minus 6, this is the major arm, minus 6 times minus 8, okay, minus, okay, you have here 1 times 1, okay, minus times minus here becomes plus, so you have plus 3. Put the determinant bar, you have the major 0 times minus 8, 0 times minus 8 minus the minus 0 times minus 1, 0 times 1, 0 times 1. Okay, finally, plus and minus here becomes minus 2. Put down your determinant bar, major arm, which is 0 times 1. Okay, minus the minus 0 times minus 6. Okay, so you have this. So delta AI1 is now equal to, this is 9 into minus 6 times minus 8, of course, gives us 48. Minus 1 times 1 gives us 1, put down a determinant bar, plus 3 into 0 times minus 8 is 0, minus 0 times 1 is also 0, okay, minus 2 into 0 times 1 is also 0, minus 0 times 6, minus 6 is also 0. So you have this. So determinant AI1 is now equal to, this is 9 into 48 minus 1 is 47. Okay, plus 3 into 0 minus 0 is 0. Minus 2 into 0 minus 0 is also 0. So determinant AI1 is now equal to 9 times 47. That gives us 423 plus 3 times 0 is 0 minus 2 times 0 is also 0. So this actually implies that determinant of that first matrix AI1 is now equal to 423. Okay, so I will simply write that here and find the determinant of the second column, which is I2. All right, so AI1 is simply equal to 4, 2, 3. I'll keep that equation, that value there. So I'm going to write here now and form a second matrix. This matrix now is a matrix for the what? Column I2. So we'll simply call that matrix AI2, okay, and then find the determinant of that matrix as well. Let's do that now and see. All right, so the second matrix is simply AI2, and that's equal to same thing. We have the values for the first column 632, 632. Now, on the second column, we simply replace everything on the second column by what? The values of the constant 900. Okay, because this is second column or the column for the I2. So we simply replace it with 900. Okay, and then the values of the third column minus 2, 1, minus 8, minus 8. Okay, so as usual now, you now find the determinant of this matrix delta AI2, and that's simply equal to same thing, 6, 3, 2, now becomes 900 minus 2, 1, and minus 8. So as usual, the very first column is positive, next is negative, and next is positive. It continues like that. So determinant of AI2 is now equal to, remember the first column is positive, so you pick it out plus, then you pick out the very first value in the first column, which is 6, plus 6, put down your determinant bar. So you block the whole of this row, you block the whole of this column, you have 0, 0, 1, and minus 8, okay? So you simply have 0, 0, 1, minus 8. Next is negative, and the first value on that row is simply what? 9. So you have minus 9. Put down your determinant bar. So you block the whole of this column for the 9, block the whole of this row. You're simply left with what? 3, 2, 1, and minus 8. Okay? 3, 2, 1, minus 8. So you put it down. 3, 2, 1, and minus 8. And finally, the third row is positive, so you put it out plus, but the first value there is minus 2, put it out minus 2, okay, you put down a determinant bar, block the whole of that column, block the whole of this row, you're left with 3200, okay, as can be seen, 3200, so you put it down, 3200, so you have this. So delta AI2 is now equal to, this is 6 into rule for determinant major product, which is simply 0 times minus 8, major row minus the product of the minor row, 0 times 1, okay, minus 9 into, here I have 3 times minus 8, major row, minus 2 times 1, minor, okay, plus and minus here becomes minus, so I have minus 2, put down a determinant bar, major row 3 times 0, okay, minus minor row 2 times 0, so I simply have this. Okay, so determinant AI2 is now equal to, this is 6 into 0 times minus 8 is 0, minus 0 times 1 is 0, okay, minus 9 into 3 times minus 8 is minus 24, minus 2 times 1 is 2, okay, minus 2 into 3 times 0 is 0, minus 2 times 0 is also 0. So I have this. So AI2 is now equal to, this is 6 into 0 minus 0 is 0, minus 9 into minus 24 minus 2 is minus 26, minus 2 into 0 minus 0 is 0. AI2 is now equal to 6 times 0 is 0, minus 9 minus 2, minus 9 times minus 26, that gives us plus 234, okay, minus 2 times 0 simply remains minus or plus 0, whichever one. So this now implies that the determinant of AI2 is simply equal to 0 plus 2, 3, 4 minus 0 still remains 2, 3, 4. Okay, so I will still put that value down here. So AI2 determinant is actually 2, 3, 4. So I will also find determinant for the last column, which is the column of I3. So you also form another matrix called AI3, and then the column or the last column, which signifies column for I3, we simply replace that column with the values of the constants. It's still the same thing. Okay, and then find its determinant. Let's do that and see. So we form the last matrix A I3, and that's equal to, so we form the matrix now, 6, 3, 2, 6, 3, 2. We have minus 3, minus 6, and 1, minus 3, minus 6, 1. And finally, in place of minus 2, 1, and minus 8, we replace it with the values of the constants, 9, 0, 0. So we have 9, 0, 0. So we transpose this by finding the determinant of this matrix AI3, and that's simply equal to, so you put it in determinant matrix, it becomes 6, 3, 2. Okay, we have minus 3, minus 6, and 1. Finally, we have 9, 0, 0. So as always, the first is positive, next is negative, and this is positive. It continues like that. So determinant of AI3 is now equal to, so we start from the very first row or column. The value there is positive, and then you pick out the number on the first column. So plus 6. Put down your determinant matrix. Same thing as always. Block this row, block this column. You're left with minus 6, 1, 0, and 0. Okay, so put that down. Minus 6, 1, 0, 0. The next is negative, so you put the negative value down, but then you have your first value on that column to be minus 3, so you put down minus 3, open your determinant bar, so you block the entire column, block this row, your left is 3, 2, 0, 0, so you put it down, 3, 2, 0, 0, and finally is positive, and then you have the first value there, which is 9. Put down a determinant bar, you block the whole of this row, block the whole of this column, you're simply left with 3, minus 6, 2, and 1, or simply 3, 2, minus 6, and 1. So you have 3, 2, minus 6, and 1. So you have this. So determinant of I3 is now equal to, this is 6 into, so major row minus the minor row. I have minus 6 times 0 minus 1 times 0, close your bracket, minus times minus here is plus, so I have plus 3, into also the product of the major row, which is 3 times 0, so I have 3 times 0, minus 2 times 0, minus 2 times 0, okay, plus 9, also the product of the major row, which is 3 times 1, I have 3 times 1, minus the minor row, 2 times minus 6, 2 times minus 6. Okay, so I simply have this. So AI3 determinant is simply equal to, this is 6 into minus 6 times 0 remains 0, minus 1 times 0 remains 0, plus 3 into 3 times 0 remains 0, minus 2 times 0 remains 0. Okay, plus 9 into 3 times 1 remains 3. Okay, minus 2 times minus 6 simply gives us plus 12. So I have this. So AI3 determinant is now equal to, this is 6 into 0 minus 0 is 0, plus 3 into 0 minus 0 is 0, plus 9 into 3 plus 12 is 15. Okay, so I3 is now equal to 6 times 0 remains 0, plus 3 times 0 also 0, plus 9 times 5 is 1, 3, 5. So this actually implies that determinant of delta AI3 is now equal to 0 plus 0 plus 135 actually is 1, 3, 5. So I have this. Now to obtain the values of these currents, let's do it over here. So to obtain I1, the first current I1, it is simply determinant of AI1 all over determinant of A, and that's simply going to be, so not forgetting, determinant of A actually gave us 228, right? Yeah, 228. Okay. Determinant of A gave us 228. So to obtain AI1, it is simply determinant AI1 all over determinant of A. And determinant AI1 gave us 423. So this is simply 423 all over 228. And therefore, the first current is simply giving us simply 1.86 amps. Okay, that's the first current. Also, to find the second current I2, it is simply determinant of A I2 all over determinant of A, and that's equal to delta A I2 gave us 234. So we'll simply have 234 all over 228, and that's equal to 1.03 amps. And finally, current I3 is simply delta A I3 all over delta A, and that's equal to determinant I3 give us 135. So you simply have 135 all over 228, which simply is, that gives us 0.59 amps. So these are the values of the three currents in that circuit. So it's best to use matrix when you have three equations, that's simply saying you're having three loops in a circuit. So the very best approach is that using matrix is better than trying to do substitution or elimination or whichever method to analyze that simultaneous equation. All right, guys, I hope you find this video very interesting and helpful. Please, if you do, don't forget to share your thoughts in the comment section, and of course, if you have any question at all, do also post in the comment section, and I promise to respond to all your questions. And if you're new to the channel, please don't forget to hit the subscribe button to keep getting updates when content as this keep dropping. I will see you in the next video with more challenging problems on Maxwell's loop method or loop theorem. I will see you in the next video. Thanks and cheers.